Good morning. Welcome to academic YouTube channel of Bodhi Prasad Group of Institution. Today I will discuss about the parallel circuit, and my topic is circuit network theory. So, in previous class we can learn about Ohm's law and series circuit. In the series circuit, what happened? The voltage applied is divided among the resistance. That will be connection of back to back resistance. The series circuit is a connection of back to back resistance. But in the parallel circuit, that is different. What happened? In the parallel circuit, we know that there is 2 points of each resistance, that is starting end and finishing end. So in the parallel circuit, what happened? The similar points, that is the starting ends and the starting ends, and the finishing ends and the finishing ends. The starting ends and starting ends, that is the finishing end and finishing ends, are connected at two distinct points, are connected across two distinct points, and that 2 points a voltage V is applied. So in this circuit diagram we see two resistors are connected in parallel. We can connect more than one resistance, that is R1, R2, R3, R1, R2, R4. But in each case, what happened? The similar ends of each resistances are connected in a point. Another point will be connected as the similar ends of the other resistance, that is the finishing ends, and that 2 points is connected across a voltage source V. So in this type of connection is known as your parallel connection. So parallel connection is mainly essential for our electrical point of view. So in this connection there is a case, that is what happened in the parallel circuit. The voltage applied V is same for each resistance, but the current I will be divided across equally or equal proportionally to each resistance. So in the parallel circuit, what happened? The voltage applied, whatever the voltage applied across the source, that voltage is reflected across each resistance. That resistance voltage is same, and but the current I that will be taken from the source will be divided equal proportionally across each resistance. So in this case, R1 and R2 are connected in parallel, and voltage source V is connected across it. This voltage V is reflected across R1, and this voltage V will be reflected across R2, and the current taking is I. The total current taking is I. Now in this point, what happened? In this point, the current I will be divided I1 and I2. That why there is two path. There is two path will be created by R1 and R2. That means two branch. That is two branch will be created by R1 and R2. Hence I current will be divided into I1 and I2. So total current I flow to up to this point, that is the A point, and that is the B point. So up to A point, the I current will be divided to I1 and I2. Again this I1 and I2 together mixed to each other to in B point and return to B. So this is a closed path. So in the parallel circuit, what happened? Voltage apply is same, but current is divided. Now the current I will be divided I1 and I2. So we can write I is equal to I1 plus I2. So in place of I, we can write I1 plus I2. Let RP is the total parallel resistance reflected across the circuit. Whatever the resistance seen across the circuit, that will be represented by RP. That is the total parallel resistance. So in place of I, according to Ohm's law, we can replace the value of I. That is, we know that V is equal to IR. So I is equal to half what happened? V by R. That is, V is equal to IR. According to Ohm's law, so I is equal to, we can write V by R. So in place of I, we can write total voltage V divided by total resistance RP. So again I1, what is I1? Now voltage is V and the resistance is R1. So in place of I1 you can write V by R1. Similarly in place of I2 what can we write? V by R2. Then V is common for each term, that's why V will be taken common and it will be cancelled out. So in place of this expression we can write 1 by Rp is equal to 1 by R1 plus 1 by R2. Now there is an LCM, there is a factor, that's why we will be taking LCM of R1 into R2. So from the first term we can find R1 cancel out, so first term we can find R2 and the second terms we can find R1. So 1 by Rp is equal to how much? R2 plus R1 divided by R1 plus R2. If we have to find out the value of Rp, that's why Rp is equal to how much? R1 plus R2 is equal to R1 plus R2. R1 into R2 divided by R1 plus R2, that is rearranging of R2 plus R1 to R1 plus R2, rearranging the R2 plus R1 to R1 plus R2. So now the value, total resistance value of the series parallel circuit is how much? R1 into R2 divided by R1 plus R2. Now we can find out the current proportion that will be divided across each resistance, that is called current division rule, So how many proportion of current that will be of I current, that is I1. So I1 is equal to, in place according to Ohm's law we can write V by R1. So in place of V we know that what is the V? V is the total current into total resistance. V is the how much? Total current into total resistance. So in place of V we can write total current into total resistance, that is the according Ohm's law. And there is divided by resistance R1, as we have to find out the value of I1, so divided by R1. So according to current division rule we can find out the value of I1 in terms of I. We can find out the value of I1 in terms of I. So we can replace V in terms of I. So I1 is equal to V by R1, and in place of V you can write I into Rp, that is total current into total parallel resistance. So again we know that Rp is equal to how much? R1 into R2 divided by R1 plus R2. So now we can replace Rp is equal to R1 into R2 by R1 plus R2. So replacing R1 into R2 by R1 plus R2, R1 will be cancel out. R1 will be cancel out. Now what is the value of I1? Now I1 is equal to IR2 divided by R1 plus R2. IR2 divided by R1 plus R2. So that is I1 is how much? Now total current what is the value of I1? Now total current I into opposite resistance. Total current I into opposite resistance divided by total resistance. So again we can write similarly, or we can write I2 is equal to how much? R1, that is opposite resistance, divided by total resistance R1 plus R2. So I2 is equal to how much? I into opposite resistance, that is the R2 opposite resistance is R1. So I into R1 divided by the total resistance, that is R1 plus R2. So this is all about the current parallel circuit and current division rule. Thank you.